Continuing on here in chapter 6, 276, we have the idea here on page 354, and it is section 6.13 of using reference variables as parameters. And just by a little bit of a recap, so we can see the distinction between the two, a reference variable and it's 6.5, a value passed by value. You'll remember in 6.5 we talked about C++'s innate aversion to passing along the only copy of data. C++ does not prefer to have a condition where if a function does not return properly, that we damage the only copy we have of a piece of data. So what it does is to preserve the original copy, it makes a copy and passes that copy when, as an argument, for example, to a function. Here we have the other side of that coin. What happens if you want to pass the original copy over? That gets to be a little bit messy because I don't have to actually pass the copy of it. I can just pass the reference location. I can pass its address in memory. So this way the function can use that address in memory and change the actual value at its source. Now, let me just briefly explain to you why that's not always the best thing. Number one is it's really hard to debug occasionally. So it's really hard to find out if everything is passed by reference, if everything gets the address of the original location, who is it that screwed up the value in that original location? You cannot see me. I think I'm pointing off camera to a whiteboard on my right-hand side. So whose responsibility is it to maintain that reference? Because you, the developer, have had function calls to go change that reference. Well, you're the one, the developer, who screwed that up. C++ is like, I told you it was not a good idea to always pass the only copy of something that you have. So here we want to be careful. What I will tell you honestly is the value of passing by reference becomes pretty clear in the next chapter when we talk about a new data type, which is the array, and a new data type, which is the vector. Here, it's not really saving you a ton of code. It's not really saving you a ton of like storage space, but it is preparing you for the idea of references and addresses. And references and addresses are every advanced coding class from here until the end of time. So this is a stepping stone that doesn't really pay out in this chapter, I will tell you the honest truth, but that's okay. So how do we deal with a reference? A reference is shown with an ampersand. So let me just show you the code sample right behind us here. It's in this direction. We have a small function called double num. What it does is it takes an int and it doubles it. That's it. As a matter of fact, it doesn't do much else of anything because it doesn't have to. So previously, we've seen that what we want to do is do the work inside of a function and then return the value of that work to whomever called to that function. Here, I don't have to return any work because all the work that was done in the original storage location. There's nothing else to change. There's no copy to send back. The work that we did here goes to the original storage location, and all of that is taken care of right here with the little ampersand in this case it's probably the function definition, not a prototype, in the function definition right here. That ampersand, referring to reference variable, is going to say I am taking, so the whatever argument I'm passing is going to refer to a variable. And rather than taking a copy, here is the actual address of that variable. When you change something here, you are not changing a copy. You are changing the value stored in the original address of that particular variable. So that little ampersand right there is a really big deal. So let's just give a couple of ground rules here. I think that that seems fair. Here you can see, excuse me, in a function prototype. So remember, this is a function definition. It is relatively fully fleshed out. Even if it is just one line of code, that actually does work. That doubles the value that was stored in whatever variable was passed as an argument to double number. It really doubles it. Here in the function the prototype rather that you see right here, void double num int ampersand. So you are telling C++ here at the function definition, so just the prototype rather, I'm sorry, here at the function prototype, that it is receiving a reference, so a pointer to an integer value. That becomes important, and that becomes important in CIS 277. I'm happy if you've heard, oh, pointer, I've heard that word before. I'm okay with that. So we have on 6.25, this is page 355. We have a really quick example of how this would run in a program. There is examples in the code samples after this, so you can go chase that with a piece of code. So here you'll notice my function prototype on line number 7, void double num int ampersand, just like it was up above. So what that means is this function receives a reference, not a copy. So it gets an address, a location that points to the actual value stored in memory. Probably memory, because this is just running on online GDB or Replit out there someplace in a virtual server someplace. So here inside of main on line number 15, you can see that we are calling to our function called double num, and we are passing it value. But C++ knows that I am not passing it a copy of value. I'm actually passing it the reference, the actual storage location to the value that is stored inside of that variable. So here on line number 15, here on line number 15, when I call to double num, I am passing the actual location for value to my function called double num. Here inside of double num, you can see this is the same function definition that we saw earlier. It takes that reference for value and it multiplies it by 2, and we don't have to return anything. The reason we don't have to return anything is, again, because we got the reference. I have inside of double num, I have access to the actual storage location for value. So when it is changed here inside of double num, even though I have not returned anything, the value of value is going to be doubled and is going to be changed. And you can see that here on line number 16. Remember that when we are done here inside of our partner function, in this case it is double num, flow of control is returned here to line 15. We end line 15. At that time, this function and all of the work we did inside of it is terminated and becomes recoverable by the system. It is no longer usable. So nothing we referred to before is permanent. There is no way to reference it any longer. And despite all of that, when I output here on line number 16 the value of value, I get here 8. It's doubled value. Each time I would call to this, so let's say Instead of line 17 being return 0, I had 3 more calls to double num. What I would end up with is 128 being the value of value, because I have doubled it 3 times in between here and there. This really does pay out, I promise. There is not a ton of support for it here in Chapter 6. I think more than anything, this is just the littlest of a breadcrumb. It's this little granule of vocabulary that I can use in Chapter 7 a little bit, and it's a little granule of vocabulary that I can say to those of you continuing on after 276 to 277 advanced C++, and I can say for all of you who are continuing on to C#, who are continuing on to other programming languages or to more advanced topics here inside of this programming language, that this makes so much powerful sense later on, and I just can't pay it off here in Chapter 6. So I am thrilled if you were like, yes, reference, and it makes sense from there. I think that that is a win, 276.